Using power series, we start by the premise y equals sigma cn x to the n and goes from 0 to infinity. Okay, so those, by the way, you want to write at the beginning of the solution so you'll get full credit. Although we should know those by heart, okay? So when you derive it, you get n to the front, cn x power n minus 1, n starts from 1 to infinity. And you need to reach second derivative because it is within your differential. So the second would be n minus 1 with the sigma. Okay, cn x power n minus 2 and starts from 2 to infinity. Okay, now we start replacing these. It is a long process, by the way, so you can jump a little. I mean, you notice that if you replace this right here, okay, y the prime, you want to multiply x squared into and then a 1 into, so it's distribution. Okay, so instead, I mean, you rewrite this and then you multiply. You are in a level, you can do it in a step, okay? So let's multiply x squared into the sigma. Now x would jump to the x. And if it is x squared near, what you do is you add those exponents. What do you get? You get n back. You get it? Okay, so that would be clear. Okay, so not to waste time, I would say x squared multiplied in, I would get sigma. N goes from 2. I want to reserve not writing infinity here, okay? Continue on. I mean, it is infinity, but I want to just for this.
Oh, it's all right. I know it.
Yeah,
it should be there.
So it's
okay if you don't write it.
n minus 1. So we said it's n back because of the 2 here. Now, when you multiply 1 by, so the sigma pops again as it is. Okay, n minus 1 cn x power n minus 2. Now I want to multiply x by y prime. So this is y prime, right? When you multiply x by, so you have x to the 1 added up again, you get n back. You get it? So by the way, those questions are puzzled in a sense. We don't provide you with x's that make trouble at the end. Okay, so those are well made in a sense to get nice answers at the end. So ncn, I'm multiplying by x, we get xn back. Minus y, it means minus this expression, which is sigma again, and goes from 0 to infinity, cn x to the n equals 0. Now we said last time the first step that you want to take after what we end by right here is to match what x exponents. Those should match. We choose a letter. We choose a letter k. Okay, you can choose whatever. You can choose I, j, whatever, but we choose k. Now this is n, so n is k in those. Okay, those will be k's as well. Okay, so there are no trouble in these even, and that is, but the trouble is in where the start value, the starting value is different. Here is a 2, here is a 1, here is a 0, so it makes trouble. And we said that second step, we want to make those values the same. They start from the same. Okay, now do you agree that this is a k now? Okay.
Yeah.
Okay, not to waste time again. I mean, it doesn't make sense. I want to rewrite those. You can even do this in the exam. I mean, this is very obvious. When n is matching the k, no need to rewrite the whole thing because all those are k's now. You see, you get it? Okay, that's it. So these are all k's now. Okay, and here it's a and k here, k. Okay, that's it. So what is it that you want to fix? I want to fix this second sigma. Okay, so when I say k is the exponent, k is n minus 2 now. How much is n?
I will be k plus 2.
K plus 2, okay, good. Now you want to replace both in the sigma. So what do we get? We get sigma changes to n now starting from 2. So the k would be 0, okay? So we say k equals 0 to infinity. Now n is k plus 2. And when you subtract the 1, you get k plus 1. And cn means this. And x power k matched. That's it. Now we have in mind that all those are now in x to the k. But I cannot add, I cannot combine unless I have the starting value for k. So again, this is a 2, this is a 0, this is a 1, this is a 0. So you want to make all those start from the same value, is it? Which value you pick? Which value you pick? Do you pick the smaller or the bigger?
I guess the smaller.
No, we said last time we match with the bigger because I
Okay.
mean if you want to match with the zero, how do you get the n to match this n equals zero or k equals zero? You cannot. You match the smaller with the bigger. I mean the smaller
Okay.
can reach the bigger, but the bigger doesn't reach the smaller. Okay. What does it mean? It means what is the biggest value in k? 2.
Mhm.
All those would be in 2. So it means if I want to approach this sigma, I want to write k0 and then k1 till I reach the sigma to be 2. Make sense? So this sigma for k0, you see there are many details. You don't write those. I mean, you cannot write k0. What do you get? Because you want to write the second sigma as well. You shift the this third sigma because I have 1, 2, 3. I want to keep this. You get it? So I have to change. Change in a sense, I want to start from the same value. Do you agree?
Mhm.
There are many details you don't want to write, but that what happens in your mind is that I want to replace a K0 here and then a K1, then I would reach this to be starting sigma K2. Do you agree?
Yeah.
This because sigma Cn x to the n, n goes from 0. When you replace n 0, you get C0 x 0. When you replace n1, so you see sigma is n values 0, 1, 2, 3 up till infinity. So you can replace whatever, and where do you reach is the value that you write. Perfect. So I pass by this. That is the same, no change. Now this I want to write it. So if I put 0, I would get 2 times 1, C2 x power 0. Okay? Now
Mhm.
a1 plus, sigma means plus. Put a 1 here. What do you get? You get 3 and a 2. Put a 1 here, you get 3 x power 1. You get it?
Yeah.
Now, where am I? I'm at the level of K2. You agree? Okay, keep
Yeah.
in mind that this is now A2. K2. Keep it. No worry. I'm done. Now I reach this sigma. It is already starting from 1. I need only 1 to be replaced. Then automatically my K would start from 2. So I come on right here. Put a 1. What do you get? You get a 1 C1 x power 1. Okay?
Okay.
What do you put right at the end? What do you put? You put 2 values. There's a minus. So there's a minus. Be careful. Open bracket. Because I want to replace this twice. N0 put it.
Yeah.
A0. So you get C0 x power 0. And you put the 1 plus. You see there's a plus here minus out. Put a 1. Okay. Now, what shall I write now next? I just saved my time not to write the sigma 2 in each, but I have in mind that all those sigmas starting from 2, I want to add them all. So plus sigma k starts from 2 to infinity. I want to put what? Because I have the same xk in all, I take xk factor. What do I want to put? I want to put the 4 sigmas in 1. Okay, so this sigma 1, 2, 3, 4, all right here. Because
Okay.
they have the same x to the k and they have the same starting value k equal 2. So those that I was talking about, I didn't try it because I want to put them all together. I mean, you are in a level, you can put them all together. Okay, imagine you want to rewrite here and then you want to take as a factor. It doesn't make sense. You should see it. Okay, because the nature of the question is long. So tell me, what shall I write in this space? What shall I write? So you start from the sigma. What do you want to write? You want to write all this. That's it. All this.
Yeah.
Okay. But in k. Huh? So it's long. It is k minus 1 ck. So where is the xk? It is right here taken. Okay.
Mhm.
I am in the second sigma. What shall I write? I write what I see. I write what I see. What is it? Plus k plus 2, k plus 1, ck plus 2. Finish. Where am I? I'm in this and that. Okay.
Okay.
It is what? Plus k, because all those are in k. Okay. ck. xk is taken. Okay. Finish. And the
Mhm.
last one is minus ck. Is it okay? Good.
Yeah.
Perfect. Now, this is the hard part. This is equals what? Equals
0.
Zero what? We said as we do in, or as we did in the method of table of the codeterminant, what did we call that method?
The underdetermined coefficient.
Yeah. As we did by comparison, we are doing right here. So this is zero what? It is zero sigma. It means zero constant. So x power 0, it means 0 x power 1, 0 x power 2, 0, 0 what? 0 x to the k. That
Okay.
zero means all this. What does it mean? Be careful. Those who have the same, we say what? Factor here. So this is a factor of x. Okay, so be careful. Students do make mistake in this step. They say this is a 0, that is a 0, which is wrong. Okay, why is wrong? Because all what is beside x power 1 should be 0. All. So those should be added. Okay, you get it? Not only those, because I have still more. I mean, all that part is a constant part. Some constant means x power 0 is a constant. X power 1. So you want to add those. Let us add these. Although I can see it, an A plus student can see it, but I prefer to rewrite the one in green properly. How do I write it properly? So your job is to collect like terms. So those constants are only 2C2 and minus C0. This is for x to the 0. You get it?
Yeah.
Now, if you didn't write x to the 0, it means x power 0 is 1. If you see it that way, it's the same thing. So those are constants. And if I'll keep it in x power 0 is okay. Now I want to collect all in x power 1 because all those should be added. So plus open bracket. This is 6. And this is a 1, C1. And this is minus. Now this is C1 minus C1. It cancels. So you are lucky. Okay.
Okay.
You are lucky. So it means 6C3 x power 1. That's it. Now this is a 0 x power 0 and 0 x power 1. What does that mean? It means 2C2 minus C0 is a 0. Okay, and it means 6C3 equals 0. You get it?
Okay.
Now you solve if you are able to do so. So right here, I would get that value. But in this part, I got a relation. Usually you find the one smaller in terms of the one bigger or bigger in terms of smaller. What do you say? We find the bigger in terms of smaller. Oh, C. So C2 should be C0 over 2. Okay, usually you expect to base your answers on C1. Now you notice that C1 vanish. Okay, you don't have anything in C1, right? You don't have anything in C1. So C1 is C1. Okay, so C1 is free. I mean, be careful here. C1 disappeared as a value, so it means it is free. C1 is free. It means it is a value we don't know. Free.
Okay.
Yeah. Okay. Always you expect to have C1 and C0 as free. And C0, what is C0? C0 by itself we don't have, but C2 depends on C0. Anyhow, so I am done with the level of no sigmas. Those have no sigma. The one with the sigma, which is right here, is all to be 0. And again, I want to collect like terms if possible. But usually you want to collect the higher C in terms of the lowers. So that should be isolated. Okay. Now, with the digital tool, I'm able to rewrite it fast. If you have any question, you ask, please. So you see, what I am going to write here is this is set to 0. Now the flash, just I'm emphasizing that I want to write the higher C in terms of the rest. Now all this is a term that you keep it on the left. You want to kick the rest to the right side. Okay. Now if I can simplify, I see I have CK, CK. If you can simplify, you do so, but I mean, no need to worry about even. So how much is CK plus 2? Now I see those have the same CKs, okay? This is CK, CK, CK. So not to repeat it, I can take CK as a factor. I want to put in K times K minus 1, right? And then plus K minus 1. But be careful, this is all shifted to the left. Do you agree? Do I change those signs? Yes. So I want to put a minus here.
Okay.
See the calculation. Now you want to change each. Okay. You want to change this minus, minus, plus. Okay. It's up to you. But for me, I want to put for all. Okay.
All right.
Now divided by how much? Divided by. Am I moving fast or is it okay?
No, it's all right.
Okay. I mean, so when I ask you, for example, okay, let's say 3x equals 7. How much is x? You say x is 7 divided by 3. Okay. When I say 3x minus 7 equals 0, I ask you to isolate x. Don't you say kick this to the other side? Okay, that's what
Yeah.
I've done here. I want to isolate this. So I kick those to the left.
Yeah, it's I get it.
Yeah,
Perfect.
that's it. And because I see ck in each, I took it. If you don't see, you wrote all those, okay?
No, it's pretty clear. Okay.
Perfect. Now, so be careful for the steps. This is always happen. If you want to put a note on your paper, because it's too messy here, and you as a student, you have to write your own notes. So what do you want to write? You write that first. This is my step. First step. This first step. Second, you write what happened. Third, you make x to the k's, and then you make the same sigma starting by. You worry about those. You add them up, and you set to 0. Blah 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 blah. Perfect. Those are the steps that you should do. Now, when I reach that, I would start by the values of the C's. So be careful. Now, K starts from, it's written, K starts from 2. So I start writing explicitly the C's, okay? So I would start by the value in the sigma for K equal 2. What happens here? So this is C4. What happens there, okay? C2. You put a 2 in every case. So this is 2 times 1. 2 minus 1 is 1. Okay. You get it? And then at the bottom, I have 2 plus 2. 2 plus 1. That's it. Exactly. Now 2 plus 1, 3, it cancels. So it is minus C2 over 4. Now you go back. How much is C2? It is. You see? Your job is to write all the C's obtained in terms of the basic ones, which is C0 and C1 always. Okay.
Okay.
So it's like recursive. This is called recursive formula based on the ones before. So how much is C2? Half C0. How much in total do I get? Now you have a half and you have a 1 over 4. If you put on your calculator, this 2, this 2 at the bottom, multiply the 4 at the bottom, you get minus 1 over 8. You can do it already. If you want to go to your calculator and you put, what do you want to put what you want, okay? But what you get is this bottom here would multiply that bottom down.
Okay, yeah.
So already I can do it fast, and that you should do. Because when I teach this in person, for students, they go to their calculator, you are taking attention out of the paper. Sometimes when you go back to the paper, you are losing some attention. You may lose to write the minus, for example. You may lose to see this as a 2. You see, those are little focus. How do I deal with this number and that number? If you know how, and you multiply, and that's it. No need to go to the calculator and worry about. Anyhow, I continue. K equal how much now?
K equal 3.
Yes. What happens? You come onto this C 5.
It's K5, yeah.
Minus, you see this minus for all, okay. Now you put a 3, so C3 times, put a 3. 3 times 2, 3 minus 1 is a 2. Okay? And then at the bottom, I have 3 plus 2 and 3 plus 2.
Okay.
Now, you should simplify. 3 times plus, you get 8n. This is 8. 8 over 4 is a 2. So I got minus 2 over 5, C3. Now, do I have C3, by the way? Yes, C3 is 0. Now, when you have one of those to be zeros is not good because you need to write more terms. It means you want to go more in K. So it is 0. It means all the odds, you see the 3 and the 5, it happens here to be zeros.
Okay.
Now, the question is, where do you stop and how many Ks do you go on? Where do you go on with the X? So this is the question. Last time we said that what are you writing, by the way, is the solution. This is the whole idea. The solution is y equal sigma Cn x to the n. This is our premise from the beginning, right? Now, if you want to write your solution explicitly, now this is a famous relation. If you put a 0, you get C0 x to the 0. Put a 1, put a 2, put a 3. So do you notice the pattern, right? What is the pattern? It's like the C number matches your x exponent. So 0, 0, 1, 1. Okay, so be careful. In the exam, sometimes they say, write your solution to x power 5. It means you want to reach C5. You get it?
Yeah.
Okay. When I want to stop at 7, for example, x to the 7, I want to find C7. So this is how you can tell how far you go on with the K. This is first thing that may specify. The second thing, if they don't specify your exponent, they specify number of terms. Sometimes they say, okay, write the first 3 terms. And most of the time, by the way, if you notice this problem, we are taking it from the book, right? They didn't mention at all. So usually we go by default 3 terms to 2 terms maximum, okay?
Okay.
So 3 terms, but be careful. When I say 3 terms, this is the whole story. Now, because your C's are recursive, all those C's are based on, those are all based on what? Based on some on C0 and another one. So what do? Is you put C0 open bracket and you put plus C1 another bracket. You get it? Okay, and when you put the C0, what do you get here is 1 because x power 0. And when you put the C1 here, what do you get? X power 1, right? So this is a first term by default. When they say I need 2, 3 terms, or by default is 2 terms more than this, it's in total 3 terms. It means you want to go 2 more K's here and 2 more K's there, and that's it. Okay? Now let us go back. Where are we? So far I have C4, right? Because C3 is a 0 in this case. Okay, so I have C4. It means I got 1 more term in C0. That's now I want to do 2 terms only. I would go 1 more here. For K equals what? 4. What do I get? So this is your reference. Do the K4. You get 6. Do the 4. So it's C4, 4, 3, 3. Right? You put the 4, you get 6 and the 5. In the bracket, be careful, you multiply those, you get 12 and 3 is 15 over 5 is a 3, 3 over 6, a half. It's minus half C4. How much is C4, you see? If that comes on, what do you do with the 8 and the 2?
This is going to be 1 over 16.
Minus, be careful for the minuses, you get a plus. So the answer is 1 over 16 C0. So in C0, I have 2 terms other than the basic one, so 3 terms in there. But you should know that if I go 1 more K, you should know that those are all zeros. Okay? If you go with the K5, if I go with the K5, I'm getting C7, but be careful. This K5 is right here, C5, and C5 is 0, right? I don't care for the rest, blah, 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 0. Anyhow, you stop. Don't go more. Because they didn't mention, so by default, it's enough. All the odd are zeros, which is C3. C3 is 0, so C1 is free. It's only C1 that you have, and the rest are all zeros. You get it? Okay, because here are the C3, the C5, and so on. Anyhow, so how much is C2? How much is C2? You go back to C2 is half C0. So C2 connected to C0. You get it? So it is, we say it is in the family of. And the word family fits here, by the way. It is in the family. Because, by the way, they mention even, there's a question in the exam, it comes, that you want to get, that is called general solution. And the general solution is based on 2 solutions, which is C0, Y0, that's C1, Y1. You may ask me, where's Y0? All this here is called Y0. and all what is in that is called y1. So these are the family solutions of the general. So the
Okay, so
general
it's
sum of
always
always
C0 multiplied by
y0. What is y0?
the
Is the
C's that we
bracket.
found,
Yes, so that you collect all
and
those.
plus C1
Let's
always.
see y1, but right here, y1 happened to be only x. Y1 here happened to be only x because the rest are all zeros.
Yeah, but we always have to put like C0 bracket plus C1 in the bracket. Okay.
Anyhow, let me so y is c3 c1. Where's c1? C1 is free. There's nothing based on c1.
Yeah.
Right. Okay, so c4, c2 is a half, we said. So half. C2 means half x squared, right?
Yeah.
Because c2 is c0. Get back. Okay. Now, how much is c4? C4 is minus 1 over 8, you see? So I want to go on minus 1 over 8. What? X power 4. So because it is c4. You see how I am dealing? Now I got
Yeah.
even c6, which is 1 over 16 plus 1 over 16 x power. I went so far, but just I'm explaining. No need like to get even to that level. Now, why are
Okay.
those zeros? Because c3, I mean, those are zeros, right? c3, c5, the rest are all zeros. For that reason, that one remains.
Perfect.
Okay, perfect. This is what you expect the scenario of solving a power series differential equation.
Okay.
Okay.